Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about classification of elements or periodic classification. In the earlier sessions, we have seen how the classification of elements was done and what are the trendings in the modern periodic table. These are all concepts we have learned in the earlier sessions. In this session, we are going to see a practice sheet related to these all concepts. So we are starting with practice sheet 1, which includes completely conceptual and single correct answer type questions. Okay, let us start this. First, let us go through the conceptual understanding type questions. So the first question, according to the law of triads, the atomic mass of the central element was merely. So the law of triads was proposed by Dauvergne. He proposed this law of triads. According to him, when we arrange the elements, these three elements in increasing order of their atomic masses, the atomic mass of the middle element or central element is being nearly equal to or equal to the arithmetic mean of the atomic masses of remaining two elements, isn't it? For example, if we take example lithium, sodium and potassium, we know the atomic mass of lithium as 9. It is 7, sorry, it is 7. And for that of potassium is 39. If we take the arithmetic mean of the atomic masses of the first and third elements, that is 7 plus 39 by 2, what do we get? We get 23, which is the atomic mass of the middle element sodium. So in this way, when elements, the three elements which are having similar chemical properties, if they are written in the increasing order of their atomic masses, then the atomic mass of the middle element is equal to arithmetic mean of the atomic mass of the first and third elements. So where it is mentioned, here it is. Okay, next one. According to law of octaves, the properties of the elements are repeated with the difference of 8 elements. In the name itself it is there, octave. Octa means 8. So first element is having, when elements are according to Newland, when elements are written in the increasing order of their atomic masses, the properties of an element are resembling with the consecutive 8th element. So for every 8 elements, the properties are being repeated. Next, Mendeleev's periodic law is based on. So Mendeleev's periodic law is based upon the atomic mass or atomic weight of the elements. So he arranged all the elements in the increasing order of their atomic masses or atomic weights. Then he observed the repetition of the properties from one element to certain some other element. So those elements he written down one to another in a group. In that way, he chosen the atomic mass as a basis for the classification of elements. Next one. According to modern periodic law, the properties of the elements are periodic functions of their. Yes, according to modern periodic law, elements when they are written in the increasing order of their atomic numbers, properties are being repeated from one element to certain other element. So here the repetition of properties are being occurring when elements are written in the increasing order of their atomic numbers. So according to modern periodic law, now we can say the properties of the elements are periodic functions of their atomic numbers. Isn't it? Yes. Next one. Lanthanoids and actinoids are called. What are they called? We know lanthanoids and actinoids are existing in the rare quantity. So they are called rare earth elements, and even they are separated from the transition elements and written separately down the periodic table. So they are called inner transition elements also. Now we can call them as rare earths or inner transition elements. Next question. The distance between the nucleus and the outermost orbit of an atom is called. What is that called? Suppose it is an atom. The distance between the nucleus and the outermost orbit of that atom is called atomic radius. So based upon the atomic radius, the sizes of the atoms are compared from one to another, and even the remaining all periodic properties are compared based upon the atomic sizes of the elements. So the atomic size of the elements is measured in terms of atomic radius. Okay, this atomic radius is defined as the distance between the nucleus and the outermost orbit of an atom, that is atomic radius. Next one, the IP1 value of magnesium is greater than that of calcium. This is due to, what is the reason for having higher IP value for magnesium than that of calcium? What is the relation between these two elements? First, we know these two elements are there in the same group. What is that group? This magnesium and calcium, this all belongs to second year group. You can see beryllium, magnesium, calcium, strontium, barium and radium. These all elements are there in the same group, isn't it? We know in a group from top to bottom, as we move from top to bottom in a group, atomic size increases. As size increases, the distance from the nucleus to the outermost electron increases if the radius increases. So nuclear force of attraction on the outer electrons decreases, and hence the removal of electrons becomes easy in the case of bigger sized atoms. Now if you compare magnesium and calcium from the same group, top to bottom size increasing. So calcium will be having greater size than magnesium, and hence calcium is having lower IP value, isn't it? So what is the reason for this now? As magnesium is having greater IP value than calcium, this is because smaller size of magnesium or larger size of calcium. Out of these two it is mentioned here. Larger size of calcium. That is correct. Okay. Next. Thallium belongs to 13th group or 3rd A group. Yes, the stable oxidation state of thallium is +1 instead of +3. This is because, so here thallium is one of the elements from 3rd A group. Aluminium, gallium, thallium, indium. These are the 3rd A group elements. These all elements are having 3 electrons in their outermost shell with the configuration ns2 np1. These are outer shell configuration of this 13th group or third A group elements. NS2, NP1 is the electronic configuration for these. Now for thallium also the same. There are 3 valence electrons. Even though there are 3 valence electrons, it forms a stable oxidation state by losing only 1 electron. That is, thallium +1 is more stable instead of thallium +3. This is because of these paired electrons. So the removal of 2 electrons from this S subshell, which is completely filled, is a little difficult and needs greater energy. So this electron can be removed very easily with a supply of limited amount of energy. That's why these 3rd A group elements will be very ready to lose only 1 electron instead of 3 electrons, because there these 2 electrons are paired and completely filled this S orbital. So this pair of electrons are not ready to not ready to come out from the atom. This is called inert pair effect. Okay, because of inert pair effect, thallium is ready to lose only 1 electron and exhibits a +1 oxidation state instead of +3 state. Okay, that is because of inert pair effect. Next, the tendency of an element to attract the shared pair of electrons towards it is called. What is it called? In a bonded molecule, two atoms, in a covalent bonded molecule, two atoms, they form a covalent bond by sharing of electrons. But if these two are of different kind, the atom which is having greater nuclear force will attract the pair of electrons towards it, and so that the pair won't be shared equally. That tendency of an element to attract this, to pull the pair of electrons towards it, is called electronegativity. Electronegativity, because of electronegativity, an element may attract the pair of electrons towards it more. Okay. Next one. The most electronegative element is, out of all the elements in the periodic table, fluorine is the most electronegative element because of its smaller size and greater nuclear charge. It is having greater electronegativity among all the elements. Okay, next. Let us see single correct answer type questions here. See the first one. Which of the following is not a Dauvergne's triad? Yes, Dauvergne has tried to classify the elements into three elements as one batch or one set. He called the set of three elements as one triad, and they are called in the honor of his name as Dauvergne's triad. So these three elements will be having similarly same chemical properties, and when they are written in the increasing order of their atomic masses, the atomic mass of the middle element will be equal to arithmetic mean of the remaining two elements atomic masses. Now see which will come under Dauvergne's triads. They are chlorine, bromine, iodine is one triad, calcium, strontium, barium is one triad, lithium, sodium, potassium is also one of the Dauvergne's triad. But this was not given by him. Sodium, potassium, rubidium was not the Dauvergne's triad. Okay, this is incorrect triad. Next, select the following pair of elements in which their arithmetic mean of atomic weights is equal to atomic weight of the strontium. So according to Dauvergne's triad, strontium is also kept in one triad set. Now the atomic mass of the strontium will be equal to the atomic mass of the remaining two elements in that pair. That's it. So what are those two elements they're asking here? So in the earlier question you have seen one triad which includes this strontium along with the remaining two elements, that is calcium, strontium and barium. And in these three, strontium is at the middle. Now the atomic mass of this strontium is equal to or nearly equal to the arithmetic mean of the atomic mass of calcium and barium. The atomic mass of these two, if you take the average of these two, that will be nearly equal to or equal to strontium atomic mass. Next one. In Newland's law of octaves, the eighth element after sodium is. So, according to Newland, when elements are written in the increasing order of their atomic masses, the properties of an element are being repeated or resembling with the consecutive eighth element. This we call as Newland's law of octaves, isn't it? Now, to the sodium, the eighth element is potassium. So let us see how he has written once. So first he has written hydrogen, and we have to remember one point here. While he was giving this classification, noble gases were not yet found. So after hydrogen, he written lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and after fluorine, neon was not found. So he has written sodium in this way. Now if you see lithium, for this lithium, the consecutive eighth element will be sodium. We have count here from here 1, 2, 3, 4, 5, 6, 7, 8. So for lithium, the consecutive eighth element is sodium. In the same way, the consecutive eighth element for sodium will be potassium. So these three elements are having similar chemical properties. If we see for hydrogen, the consecutive element is fluorine. So this will be having similar chemical properties. So in this way, for sodium, the consecutive eighth element is being potassium, and hence he consider these elements are having similar chemical properties. Right? Next, the long form of periodic table has. Here they're asking about the number of horizontal rows and vertical columns in the modern periodic table. How many horizontal rows are there? Totally there are 7 horizontal rows which are called as periods, and there are totally 18 vertical columns which are segregated as groups. Now we can say There are 7 horizontal rows and 18 vertical columns in the modern periodic table. Okay. Next, the liquid non-metal is. So there are only two elements in the liquid state in the overall periodic table at normal temperature or room temperature. Those are mercury and bromine. Out of these two, mercury is a liquid metal, whereas bromine is a liquid non-metal. They asked here the liquid non-metal. So bromine is the liquid non-metal, whereas mercury is a liquid metal. Next question. Which of the following represents the general electronic configuration of D block elements? D block elements means the elements for which the differentiating electron enters into D subshell of the outermost shell. Those are called D block elements. If you see in the periodic table, suppose it is periodic table, let us consider outlines. Suppose if you consider this as a periodic table, the elements which are at the middle in these 10 columns are called as a D block elements. To say simply, the B subgroup elements here third B to first B, third B to 8th B and first B, second B group are there. So these B group elements are called D block elements. For these all, the last electron enters into D subshell of penultimate shell. We said what is meant by penultimate shell? The shell which is at the last of the outermost of that or last of shell is called outermost shell. Last but one shell is called penultimate shell. So for these all D block elements, last electron or last which is also called differentiating electron. So the differentiating electron enters into D subshell of penultimate shell. Now their configuration will be outermost S subshell and penultimate shell D subshell. These two will be represented in their valence electronic configuration. Actually here should be 1, n minus 1, 1 to 10, ns 1 to 2. This is their general electronic configuration for D block elements. Okay, n minus 1, D 1 to 10 and ns 1 to 2. So first they will fill ns orbital. After filling ns orbital, the differentiating or last electrons will come and enter into D subshell of the penultimate shell. So this will be the outermost configuration of these elements. Next, in the long form periodic table, almost all non-metals are placed in. Yes, in the modern periodic table, non-metals mostly they are present at the extreme right side in the 6 columns. So the 6 columns together called as P block elements. Except why they are called mostly, almost why they called means except one element remaining all are there in the P block itself. What is that accepted element? That is hydrogen. Hydrogen is present in the S block along with the alkali metals. Except that hydrogen, remaining all non-metals are present at the right side in the P block only. That's why we say almost all the non-metals are in the P block. Metals are present in all the blocks. They are in the S block, P block, D block and even F block also. Metals are spread over in the periodic table, but mostly non-metals are only in the P block except hydrogen. Next one. Which of the following elements are known as typical elements? Yes, in the periodic table, one period elements are called typical elements. These period elements will represent the chemical properties of those all elements present in that particular group. That is why these period elements are called typical elements. What are those elements? Yes, we know they are third period elements. Sodium to argon. These elements will represent the properties of the elements present in that group. Suppose if you see sodium, sodium will give the character representation about the properties of alkali metals. If you see magnesium, it gives representation about the alkaline earth metals chemical properties. In this way, These third period elements are giving the representation about the chemical properties of those particular group elements, and hence they are called typical elements. Next, which of the following statement is correct about iron? What is correct about iron? See, iron belongs to F block. Is it correct? No. Iron is not belonging to F block because F block elements are written at the bottom of the periodic table. But iron is at the middle of the periodic table. So it is not belonging to F block. It belongs to first transition series. Yes, this is correct. If you see the periodic table, that is a draw here once again. Suppose this is periodic table. So there are 4 horizontal rows in the D block. These are called transition elements. We have studied about this. These are called transition elements. Out of these, first horizontal row or fourth period elements in the D block are called first transition series. In the first transition series only, in the 8th B group, iron is present. So iron is called now first transition series element. This is correct. It belongs to third period. No, iron belongs to fourth period. It belongs to group 7. No, it is also not correct. To which group iron belongs? Iron belongs to 8th B group. So only correct statement about iron is here. It belongs to first transition series. What is meant first transition series? In the D block element, there are 4 horizontal rows. These all together called as transition elements. Out of these, first horizontal row or fourth period D block elements are called first transition series, and next second, third, fourth. Okay. Next, the correct order of ionic radius. See, here certain elements are mentioned and they're asking to find the correct order of their ionic radius. So if it is asked a question like this, there will be certain relation between the elements given in the options. Observe once those elements, so you can identify the relation between them. How do they relate? Yes, if you see sodium, potassium, rubidium, cesium, these all elements belongs to same group, isn't it? Yes, they all belong to alkali metals group, first A group. So in this way they can be represented in the periodic table. Sodium, potassium, rubidium and cesium. French, of course, there will be hydrogen lithium also. So this is a position of these elements in the periodic table in the first A group. Now they're asking to compare their ionic radii or size. We know in a group from top to bottom, atomic size or atomic radius increases because as you move from top to bottom in a group, a new layer is being added to an atom as we move down. So because of the new addition of a new shell, atomic size increases. Even the ionic radius also will be increased as we move from top to bottom in a group. Now, which element will be having the least size? Sodium. And which will be having greater size or ionic radius? Cesium. See where that order is mentioned, from sodium to cesium or cesium to sodium. All they mentioned in the decreasing order. Now it should be started with cesium and it should be end with sodium. So is cesium, rubidium, potassium, sodium. Where it is mentioned? In the first one here. It is the correct order. It is the correct decreasing order of their ionic radii. Okay. Next, of the following elements of third period, the strongest reducing agent is. We need to know first what is reducing agent. Reducing agent. First, let us see what is reduction. So we can come back to reducing agent. Reduction means the gain of electrons. So gaining of electrons is called reduction. Now, reducing agent means the element which will help in the reduction. That means the element which gives electrons to others is called reducing agent. So by giving electrons, it will help the reduction of other substances. So it is called reducing helper or reducing agent. The element which can lose electrons easily will act as a good reducing agent, isn't it? Now say, out of these four elements which can lose easily electrons, that will be good or strong reducing agent. See, which can lose electrons easily among these four? That is sodium, because it has a greater size among these all. These all belong to same period. In a period from left to right, size decreases. So the left side one is having greater size. Sodium will be having greater size among these all. So if it is having greater size, it can lose electrons easily and hence it will be a strong reducing agent. That is sodium. So in the opposite way, if you see, chlorine will be strong oxidizing agent because it can attract the electrons very easily towards it and it can help in the oxidation of other elements. So chlorine can be told now good oxidizing agent, whereas sodium is a good reducing agent. So the next one. One element has mass number 39. Its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. So they have given mass number and they mentioned here its electron configuration. Now what they're asking, the true statement for the element is, what is correct about this statement? From the configuration we can identify this element as, what is the element? Potassium, isn't it? Because if you observe here the number of electrons in that configuration is 19. The element with the 19 electrons or 19 atomic number will be potassium. Even the mass number is 13 is also 39 is also mentioned here. Now the true statements about this potassium they're asking. It has the highest value of ionization energy. Is it true? No. Actually, these elements of first A group along with potassium remaining elements are also having lowest IP values or lowest ionization values among the elements of the particular period. So it has it has lowest, not highest. Next, it is transition element. Is it true? No. Potassium is a alkali metal and it is S block element. What are transition elements? D block elements are called transition elements. So it is wrong. Next one, it is isotonic with argon. What is meant by isotonic here? The atoms which are having same number of neutrons are called isotones. If we count the number of neutrons in potassium, what do we get? We know it is given electronic configuration with 19 electrons. So there are 19 electrons. At the same time, 19 protons also will be there because they mentioned it as an element without charge. Isn't it? Now there will be 19 protons and mass number is given 39. From these two, we can calculate its number of neutrons. What is the formula to calculate number of neutrons? Number of neutrons is equal to mass number minus atomic number. So here mass number they mentioned as 39 for potassium and atomic number, because number of electrons or number of protons is being 19, atomic number will be 19. Now the number of neutrons in potassium is 20. If you compare the number of if you calculate number of neutrons in argon, what do we get? They mentioned here its mass number as 38 and the atomic number is given 18. Then number of neutrons we get it as 20. So both the atoms they are having same number of neutrons. The atoms with the same number of neutrons are called isotones. Now we can say this element mentioned here is isotonic with argon 38. This is correct. And what they have in fourth option, it has a stable configuration. Is it a stable configuration? No, because it has only one electron in its outermost shell in the 4s1. So if there is only one electron in the outermost shell, it won't be stable. It is an unstable element. Only the correct option is here. It is isotonic with argon 38. Okay. Next, the increasing order of ionic radii of the given isoelectronic species is. See the relation between the elements in these options. All options contain same ions. Now, if you observe the relation between these all, they are isoelectronics. Okay, in the question itself it is given isoelectronic species. What does it mean by isoelectronics? The ions or atoms or molecules. Simply you can say the species. The species which are having same number of electrons are called isoelectronics. So if they are isoelectronics, size can be compared based upon their nuclear charge. We can say the among the isoelectronic species, as nuclear charge increases, size decreases. So which is having greater nuclear charge, that will be having smaller size. Say which is having greater nuclear charge among these all, we know calcium will be having 20 protons, that means 20 units positive charge, whereas for 19 it is 19 units, for potassium it is 19, for chlorine it is 17, isn't it? For sulfur it is 16. Okay, so for chlorine it is 17 and for sulfur it is 16. Now they're asking to find out the correct increasing order of their size or ionic radius. Among these all, which will be having the least, the one with the greater nuclear charge, that is calcium, and next potassium, and then chlorine, and at last sulfur. So this will be the correct increasing order of atomic sizes. Okay, now this is correct. Now, next one. In which group all elements do not have same number of valence electrons in the modern periodic table? Generally, in the modern periodic table, the elements present in a group will be having same number of valence electrons. It is happening almost in all the period, all the groups, except one. That is noble gases. That is 8th A group elements. If you say those elements, what we can name them? We can say helium, neon, argon, krypton, xenon, and radon. These are the elements present in the 8th A group or 0 group. If you observe the electronic configurations of these all elements, these all elements except helium are having 8 electrons in their valence shell configuration. So we can generalize the configuration as ns2 np6 for these elements except helium, because helium is having configuration 1s2, so its valence configuration will be now ns2 only. So in this group only, in this way the general electronic configuration is being varied between the elements. So except helium, remaining are having different. In all the remaining groups, all the elements will be having same kind of valence electronic configuration except this 8A group or 0 group. Okay, next one. Most electropositive element among the following. See the elements present here: fluorine, cesium, helium, and chlorine. Fluorine is most electronegative element. The highest electronegativity is for fluorine, and most electropositive element, that is alkali metal, higher element is cesium. So this is a most electropositive element. What about helium? Helium is the element with highest IP value. Highest ionization potential is there for helium. What about chlorine? Chlorine is the element with the highest electron affinity. Now they're asking about highest electropositive element, that is cesium. Okay, this is the progress sheet. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates and recorded videos.